Welcome to the Crazy Hat Chemist. So today we're doing the third video in thermochemistry. So let's get moving. Bam! So today we're going to be talking about the thermodynamics equations, or the thermochemistry equations here that are really important to begin with. So here we go. Anybody want to be a doctor? I do. So if you do, what is the qualifying exam that you need to take in order to become a doctor or accepted into medical school? Anybody know that? Think about it. Here it is. It's called the MCAT, or the Medical College Admissions Test, aka MCAT. Okay? Many people study for days and days and days to get into medical school, and you need to get a qualifying exam in order to do that. So why am I talking about medical school? Other than that, my mom is a nurse practitioner? No, that's not quite right. Okay? So here it is. Q equals mc delta T. That is the thermodynamics equation that I'm considering and thinking about here right now at the moment. So how does this have to do anything with medical school? Well, it is the qualifying exam. It's the college admissions test. So hopefully you see that all right there. It's the qualifying medical college admissions test. It's all right there. If you remember that part, you can easily get that equation. Not a problem at all. Okay. It is the quantitative relationship between the temperature change and heat transfer. Okay. All right. Q equals mc delta T. Delta T is equal to the temperature final minus the temperature initial. So what we're going to do is substitute in to delta T Tf minus Ti. And then once we substitute that in, this is what we're going to get right here. So it's Q equals M Cp and multiplied by Tf minus Ti. That Tf minus Ti is the delta T, which is the change in temperature. Remember, the previous lesson, the previous video, was talking about the specific heat capacity, and that is the Cp, so you should be familiar with that. Okay? These are the units for this equation here. So you absolutely must know the units associated with each letter. It's essential. It will help you out with the math of the equation as well. So what does Q represent? Q is joules. Okay, what does M represent? That's a mass. That will be in grams. The specific heat capacity is joules per gram degree Celsius. So the grams and degrees Celsius are in the denominator and the joules are in the numerator. Okay, and then the temperature final minus the temperature initial, they must be in the same units of temperature, and that will probably be in degrees Celsius. You could have had Kelvin in here in replace of the degree Celsius, and that would have been fine too. It's actually not going to change the number because the interval on degrees Celsius and Kelvin is the same. Okay, here's another equation that you're going to have to use frequently here, and that is Q, which is the heat, that is the Q of water plus the heat, that is Q of metal, and that's equal to 0. It could actually be Q of metal plus Q of metal, or it could be Q of water plus Q of water. I just have it as water plus metal because that's typically what we do in a laboratory activity. Okay, we could rearrange this equation so that it looks a little bit different, so we get rid of the 0 there. Maybe that bothers you, but that 0 there is very important here, and I'll talk about that in just a second. So we're going to move one of these terms to the other side. Hopefully that math is not a problem for you. We've subtracted the Q of metal on both sides, and now we get Q of water is equal to negative Q of metal. We're going to take advantage of that equation. Either one of those two equations is truly the same equation. Just make sure you use whichever one you want to is the simplest for you. Okay? So temperature final of the water is equal to temperature final of the metal. This is when there is thermal equilibrium. That's why the sum of the Q water plus the Q metal is equal to 0, because that's when it has reached thermal equilibrium. That is, if I have a hot piece of metal and a cool cup of water, and I throw the hot piece of metal inside the cool cup of water, then that hot metal is warmer. It will transfer its energy to the cool cup of water. The water will absorb the energy from the metal, and the transfer of heat will go from the metal to the water until that is the temperature is the same for both the metal and the water, and that's when thermal equilibrium has been reached. And that's why the temperature of the water and the temperature of the metal is the same here on this. So it's a very key concept here that is must known, and it's not necessarily always stated in the problem, but it's assumed that you know that. Okay? All right, so that was another video, another lesson. I hope you enjoyed that. Here's another crazy hat. I heard a dog barking out there earlier today, and so I chose this hat here, although this one is a wolf. Okay? Give me a thumbs up if you like that video. Please subscribe to my YouTube channel, and I will see you next time for more chemistry. Bye now.